Let's look at some examples of solving radical equations. Let's take a look at x minus 5 is equal to the square root of 4x minus 15. In this particular case, our radical is isolated on the right side, so we do not have to worry about adding, subtracting, or even dividing by anything. So what we're going to do is we will raise both sides to the power that's equivalent to our index, which is the understood 2. Remember to multiply x minus 5 times an x minus 5. That will give you x squared minus a 10x plus 25. On the right side, your square and your square root will cancel out, leaving you strictly what is underneath the radical. We need to move everything to one side, setting our equation equal to 0, so we will subtract our 4x and we will add our 15. This will give us x squared minus 14x plus 40, and that is going to be equal to 0. We need to solve for x. You can do this in multiple ways. You can use the quadratic formula, or you can factor. If you think about the factoring, two numbers that multiply to give you a positive 40 and add to give you a negative 14, they would both have to be negative numbers because you're adding to get a negative and you're multiplying to get that positive, so negative times negative would give you positive. And we can go with a negative 10 and a negative 4. So that would be x minus 10 times an x minus 4 equal to 0. So I would go with x minus 10 is equal to 0 and x minus 4 is equal to 0. So x is equal to 10 and x is equal to 4. Our last step is to check our solutions. So I will check x equals 10. So we get 10 minus 5 is equal to the square root of 4 times 10 minus 15. So 10 minus 5 will give me 5. 4 times 10 is 40 minus 15. 40 minus 15 is 25. And the square root of 25 is 5. So 10 does check out. We do still need to check the 4 because sometimes both solutions will work. 4 minus 5 is equal to a 4 times 5 minus 15. So this would give me a negative 1 is equal to the square root of 20 minus 5. I'm sorry, minus 15. And I do not know why I put a 5 there. That should be a 4. And so this would actually be a 16 instead of a 20. So 16 minus 15, that would be a square root of 1. And I get negative 1 is equal to 1. No. So I reject this one. That would be an extraneous solution. So x equal to 10 is my only solution in this case. Let's look at another one. Let's look at 2 times the cube root of 4x minus 8 is equal to 4. Now in this particular case, these two things are multiplied. I need to get, again, my radical alone. So I need to divide both sides by a 2 before I begin. I need to get that radical by itself first. So I'm going to get the cube root of 4x minus 8 is equal to 2. Now I can raise both sides to a power equivalent to my index, which in this case is actually a 3. So I'm going to cube both sides. When I cube both sides, this gives me 4x minus 8. 2 raised to the third power is 8. Then I solve. I add 8 to both sides. So that gives me 4x is equal to 16. And then I divide both sides by 4, and I get x is equal to 4. Then I go back and I check. And so I have 2 times the cube root of 4 times 4 minus 8 is equal to 4. So 2 times the cube root of 16 minus 8. 16 minus 8 is 8. The cube root of 8, I need 3 of the same number. That is going to be 2. So I have 2 times 2, which is 4. 4 equals 4. So my solution is 4. Let's look at one more. I have the square root of 9x minus 15 plus 6 is equal to 2. So again, we need to isolate the radical. So I'm going to subtract 6 on both sides. And this gives me that the square root, 9x minus 15, is equal to a negative 4. And actually, I can stop here. I cannot have a radical equal to a negative number. There is no number that I can take the square root of that will give me a negative number. Now I could still solve this, but I would get a no solution. Anytime you have radical equal to a negative number, you can stop and you get no solution or that empty set. You cannot have the radical equal to a negative number. So be careful about that.